Welcome to Ixia product demonstration.
In this session, we will be demonstrating how to use Ixia PCE solution to test PCC's ability to process and learn SR LSPs instantiated by the PCE. The topology consists of a PCE emulated by Ixia port connected to a network of PCCs which are the system under test. Ixia PCE does not have the ability to build and dynamically keep updating traffic engineering database learned via BGP-LS or SR. One needs to configure PCE-initiated LSPs statically. The device also has ISIS configured to learn the IP reachability of the PCCs under test. Let us see how an Ixia PCE can be configured. The stack named PCC Group 1 consists of a set of PCEP channels to the PCCs under test. The PCE-initiated LSPs are also configured over here for each channel. Each LSP consists of a set of intermediate hops, and these hops are defined as ERO subobjects within a single ERO. The subobject value can either be MPLS label to reach a particular hop or IPv4, IPv6 address of the hop. Within a PCC group, all LSPs will have the same number of ERO subobjects. If there is a need of having some PCCs with LSPs having N1 ERO subobjects and some PCCs with LSPs having N2 ERO subobjects, then user needs to configure two separate PCC groups. In this example, it will be shown how two groups of PCCs can be configured, one group having 3 ERO subobjects and the other group having 1 ERO subobject. To add a new PCC group, one has to hover the mouse over PCE and select Add Protocol option, and then select the PCC group checkbox in the pop-up window. Next, the number of PCCs needed to be configured for each PCC group. To configure that, hover over PCC group and select Edit Stack Multiplier. The required number of PCEP channels should be configured as the stack multiplier. So, there are two PCC groups, one having 2 PCEP channels and the other having 3 PCEP channels with the PCCs under test. Next, one needs to configure the IP address of the PCC with whom the PCEP channel will be established. And then, the number of PCE-initiated LSPs for each PCC in the group needs to be configured. The number of LSPs can be scaled as per the requirement of the test. Bundling of PC-initiated LSPs is also supported by configuring the max LSPs per PC initiate to more than one. SR PCE capability needs to be enabled for this test as the test is dealing with SR type of LSPs. User can set up the rate at which the PC initiate messages should be transmitted by the PCE. By varying the rate of PC initiate message transmission, the user can test the efficiency of the PCCs so far as LSP processing is concerned. Ixia PCE also supports MD5 authentication. Once enabled, all PCEP messages exchanged on a channel will be encrypted as per MD5 authentication rule. Next, let's see how to configure the initiated LSPs which will be sent out in PC initiate message by the PCE. The PC initiate message consists of several objects, some of which are mandatory and some optional. User can select the different objects which should be included in the PC initiate message. One can exclude certain mandatory objects in the PC initiate message and test PCC's ability to generate PC error message for missing mandatory objects. To define a PC initiate LSP, one needs to first configure the endpoint object that consists of source and destination IP addresses. Ixia supports both IPv4 and IPv6 types of endpoints. Next, let's see how the EROs can be configured. One needs to configure the number of ERO subobjects to be included in the PC initiate message. Depending upon the number, similar type of subtabs will be exposed. As shown here, 3 subtabs have been exposed as ERO1, ERO2, and ERO3. Each subobject details can be configured within this tab. All types of SIDs are supported and configurable. All types of NAIs that are defined in the PCEP specification are also supported as shown here. There is control over the different flags defined in the specification. User can set invalid SID and NAI type flags combination and test PCC's ability to generate PC error message if erroneous EROs are received. As per PCEP specification, there can be multiple metric objects for a single PC-initiated LSP, and Ixia PCE solution supports multiple metric configurations. Similar to ERO, for metric, one needs to configure the number of metrics and same number of subtabs gets exposed, named metric 1, metric 2, etc. as shown here. All types of metrics are supported as defined in SR PCEP specification. All other objects like LSP, bandwidth, LSPA, SRP can be configured selecting each subtab as highlighted. PPAG is also supported. Ixia PCE can create association group of working and protect SR LSPs and modify or remove association runtime. Let us now start the protocol and validate the test results. Once the protocols are started and sessions get established, the user needs to validate the test result. Ixia PCE supports multiple different types of statistics such as session configured, sessions up or down, session flag count, along with transmit-receive statistics of different types of PCEP messages exchanged. Like we can see PC initiate message transmit, total initiated LSP transmit to check whether PCE has sent all the configured LSPs or not. If bundling is configured for PC initiated LSPs, each PC initiate message will have multiple LSPs packed, resulting in different values of the two statistics. Based on validity of PC initiated LSP message, the PCC will either send PC report message or PC error message for each of the LSPs received. This can also be validated by the statistics like PC report message received and PC error message received. It also has the ability to drill down per channel to check what is happening in each PCEP channel. As can be seen, there are 5 different rows for 5 PCEP sessions configured, and user can verify the test result for each session separately. Next, we shall see how PC update can be sent out from Ixia PCE. If any object parameter is changed on the fly and applied, PC update will be sent out by the PCE with all the changed information. For example, let's change the ERO label and the bandwidth while the protocol is running. Then click on Apply, which will trigger the sending of PC update message with the changes done. User can verify at the PCC whether it is able to process the PC update message properly or not. LSPs can be removed as well on the fly by disabling the active checkbox of initiated LSP at PCE. We can see the PC update message transmit is showing the PC update message count sent by the PCE. Similar on-the-fly change of any other object parameters like symbolic path name in LSP object or change in metric value or any LSPA attributes will result in PC update message transmission by the PCE. Ixia PCE can remove initiated LSPs as well on the fly by disabling the active checkbox of initiated LSPs and then apply. This will result in PC initiate message with R bit set, which will trigger the PCC to remove a PCE initiated LSP. We can see that both PC initiate message transmit and remove initiated LSP transmit count has increased by 20. This is how an end-to-end testing can be done using Ixia PCE solution to validate a PCC's capability of setting up, updating, and removing PC-initiated SR-LSPs.
Thank you for your time. Please watch our other product videos for more information.